We are starting with work, energy and power, lecture number 1. First point, start writing. Three methods to find work done. Three methods to find work done. First is work done by a constant force. Work done by a constant force. First point. Suppose F bar is given as 2I cap plus 3J cap Newton. If this kind of force is given in the question, you realize that it is a constant force, not 2 along the x-axis and 3 along the y-axis. So this is a constant force. So first you have to realize whether it is constant force or it is a variable force. So we know it is a constant force. Second concept, you apply work done formula. Work done ka formula is what? F bar dot S bar, which can also be written as Fs cos theta, where this angle is F bar, this force is F bar, this is S bar, and the angle between them, the smaller angle between them is how much beta? Theta. You know theta can be acute, theta can be obtuse, and theta can become 90 or 0, whatever it is. So if theta is acute, so cos theta will be positive. So work done will also be positive beta. If theta is obtuse, cos theta will be negative. So work done in that case will be what? Negative. And can anyone tell me if theta is 90? So work done will become what? 0. Positive work done means supply of energy. Negative work done means gain of energy. And no work done, so no energy is lost or gained. This I'll explain it in the numericals when I'll do the numericals to you. You'll understand it properly. Third concept, work done is F bar dot S bar, but S bar can be written as final vector minus initial vector. You know S bar is R final minus R initial, no? Where this is the position vector final and this is the position vector initial. Now we'll take a question. Example 1. Can I say there is a force acting 5 Newton, 37 degrees with respect to horizontal. 37 degrees with respect to horizontal. And the body is displaced from 2, minus 4, 6 to 6, 2, minus 2. Find the work done in this process. This force is acting 37 degrees with respect to x-axis and the body is displaced from this vector to this vector. This position to this position because of this force. I want to find the work done. Okay. How to find it? Can I split the force into 2 components? This will be F na beta, this is F bar na. Direction is 37 degrees. Can I write this as what? F cos 37. Cos 37 is beta 4 by 5. 4 by 5 of 5 will become what? 4 Newton. Can I say this is your Fx? And will be this equal to? This will be phi sine 37. Sine 37 is 3 by 5 will become 3 Newton, will become Fy is 3 Newton, right or not? Solution will become what? F bar will be Fx I cap plus Fy j cap. Bolo. What is F bar? Fx I cap. What is Fx? 4 I cap plus 3 j cap. What? Newton, na beta? And how to find displacement? Displacement vector will become R final vector minus R initial vector. What is R final vector? 6 I cap plus 2 j cap minus 2 k cap. And what is R initial vector? 2 I cap minus 4 j cap plus 6 k cap. Can I subtract this from this so I'll get S bar directly? What is 6 minus 2? 4. So it will be 4 I cap. 2 minus 4 will become 6j cap. And will be minus 2 minus 6 will become minus 8k cap. Correct or wrong? This answer will come in what? Meters. This is your S bar. And what will be the work done? It will be F bar dot S bar. So F bar with S bar, I with I, J with J, K with K. 4 4s are 16. I dot I 1. 3 6 are 18. And K, this K is not there, will become 0. Understand what's happening? How much is the answer? This is positive work done. Are you understanding? Because the angle which it is making is acute angle. Are you understanding what's happening? This is the work done. Come on, write this down fast. There is a block of 2 kg and an external force of 16 Newton is applied to pull it. Find the acceleration of the system, the displacement, the work done by all forces in a time of 2 seconds. In a time of 2 seconds. Who is acting down? The weight. Can anyone tell me how much will be the weight? So weight over here is 20 Newton. Can anyone tell me where will the block accelerate? Down, because the net force is downwards. No, this is 20 is bigger than 16. So the block will accelerate down. The displacement will also be down, right or not? Since it is accelerating downward, the displacement will also be downwards. Now what is the general formula for acceleration? Net pulling force upon total mass. So how much is the net pulling force? 20 minus 16 by 2. 2 meter per second square. Where? Downwards. Huh? This way. This is like Newton's laws of motion which we have done before. I want to find S. Can I say S is ut plus half a t square? Because it is acceleration is constant. So I can apply kinematically equation will become half a t square. Half a is given as 2, t is given as 2 square will become 4. So how much is the displacement beta? 4 meters. Where? Downwards. Correct, na? So this is A and this is S. Work done by all forces individually. One is capital F and another is weight. So I have to calculate work done by F as well as work done by weight. First I'll calculate work done by weight. What is the formula for work done? Fs cos theta. How much is the force of the weight? 20. How much is the displacement beta? 4. And cos 0 because both are going down. Weight is also down and displacement is also down. So what will be the answer beta? Plus 80 joules. This is the work done by whom? Weight. What is the work done by capital F? Fs cos theta na beta. How much is the F? Up 16. Where is the displacement? 4. And how much is the angle between them? 180. So how much is the answer? Minus 64 joules. That is the work done by capital F. Now we'll explain the meaning of plus sign and minus sign. Plus sign over here means it is supplying 80 joules of energy. Out of that he is gaining how much? 64 joules of energy. So how much is the left amount of energy? 16 joules. So can I say work done, that is net, will be work done by weight minus work done by F. So it will become what? 80 minus 64, or you can write this as plus, so it will become minus automatically. So that will become what? 16 joules of energy is the net work done. Did you understand what's happening? This can also be done by another method. Can I say work done net will be net force into net displacement? How much is the net force? 4. 20 minus 16, no? 4 net is down. And how much is the displacement down? 4. So how much is the answer? 16 joules, and you can do the same answer. Did you understand this thing? So if they ask you work done by individual forces, it can become positive or negative, whether it is going up or down. And work done by net force will become net force into displacement in the direction of the force. Now I'll give you the direct formula for work done. Work done is force into displacement in the direction of force. Or it can also be written as work done is displacement into force in the direction of displacement. Are you understanding what's happening? This one. Write this down first. Pulley system is given. Atwood's machine. I want to find acceleration, displacement, work done by all forces in a time of how many seconds, beta? 2 seconds. How to find acceleration of the system? Come on. How much is the weight acting? 20. How much is this? 40. This is going up and this is coming down, right? You know it. What is the general formula for acceleration? Net pulling force upon total mass. How much is the net pulling force? Try to make it straight. 40 that side, 20 this side. So 40 minus 20 will become 20, right? By how much is the total mass? 6. So will become 10 by 3 meter per second square, right or not? Or if any of this system appears, you can use the formula m1 minus m2 upon m1 plus m2 into g. This is also termed as an Atwood's machine. The system is also termed as Atwood's machine, and the formula for acceleration will be this, where m1 will be the bigger mass and m2 will be the smaller mass. Do that, you get the acceleration also. Achha, I need to find the tension also. Why? Because they have asked you work done by all forces, and all forces mein one of the forces is tension also. So you know there is tension here and there's tension here. So you can apply free body diagram of anything. Can I apply on 2 kg? So on 2 kg if I say it's going up, so T minus 20 down is equal to MA. So T minus 20 is equal to M is 2 and A is given as what? 10 by 3. So T will become 20 plus 20 by 3 will become 80 by 3. What? Newton? Yes or no? So you got A, you got T. You got A. Here you find S. S. What are the formula for S? Half AT square. Half A. A is given in the question as 10 by 3. And T square is going to become what? 4. So what is the answer? 20 by 3 meters. So this is going 20 by 3 meters down and this is going 20 by 3 meters up because it is an inextensible string. Inextensible means it cannot stretch. This is S. Lastly, we need to find work done by all forces. Now, individually on 2 and individually on 4, there are two forces you can see. So suppose if I say on 2 kg, how many forces are there beta? 2, no? Work done by T will be Ts cos theta. How much is T? T is given as 80 by 3. How much is the displacement beta? 20 by 3. And T is also up and displacement is also up. So it will become what? Cos 0. It will become what? 1600 by 9 joules, right? Plus. Similarly, work done by 20 will become 20 into displacement is 20 by 3 and cos 180, yes or no? Because where is 20 Newton acting down, where is the displacement up? So work done will become negative. So how much is the answer? Minus 400 by 3 joules. This much is the supply energy, this much is the gain of energy. So the left amount of energy will be this minus this. You understand it? Similarly on 4 kg, you can do the same thing. Work done by 40 will become 40 into 20 by 3, that is S into cos 0 because it is going down. It will become 800 by 3 plus joules. And what is the work done by tension? T is given as how much in the question as 80 by 3. Displacement is 20 by 3 and it will become cos 180. So it will become minus 1600 by 9 joules. Yes or no? You can see. Okay. So this is on 4 kg and this is on how much? 2 kg. Are you understanding? Come on. 2 kg block. 10 Newton force is being applied 37 degrees with respect to horizontal. Mu s and mu k means there is friction on the road. How much is the acceleration, displacement and work done by all forces in a time of 2 seconds? Solution. Resolve. This will be cos 37 is 4 by 5. 4 by 5 into 10 is what? 8 Newton. 3 by 5 will become 6 Newton. What is this? Normal reaction. What is down? 20. Can I say up is down? Because it is very necessary to find normal reaction. So can I say n plus 6 equals 20 down? So n will become what? 14 Newton. Yes or no? Fs is mu s into n. How much is mu s beta? 0.4 into 14. Understand? How much is this? Correct? What is Fk? Mu kn. Right? You get this? And this is Fs what? Maximum, because to overcome it, it will be maximum value of static friction. And once it is in relative motion, Fk will come into picture, right or not? Need acceleration. What is the acceleration? The general formula. Net pulling force upon total mass. Pay attention over here. What is the net pulling force? What is the front force which is pulling? 8. What is the backward force which is applying? Fk or Fs? Whenever it is accelerating, it is in motion. So who will come into picture? Kinetic or static? Always remember, so it will become big F minus Fk. We have done this before also, upon M. Don't take Fs, it is 0. F is 8 minus Fk. How much is Fk beta? 4.2. By M. M is given as how much? 2. Okay. So how much is this answer? That is 1.9 meter per second square forward. A you got S. S will become what? Half A T square. Half A is what? 1.9 T square. T square is 4. 3.8 meters. Got it? Work done by all forces. Acha, how many forces are there? Up also are there, front also there, back also there. So can I say work done by 8 Newton will be 8 into displacement into cos 0 beta. Whatever answer comes will become positive joules, right? How much will be the work done by Fk? Fk is back. How much is the Fk ka value? 4.2. How much is the displacement beta? 3.8 into cos what? 180 na? So how much is the answer? Minus that much joules. That means this is supply of energy and this is gain of energy. Means he is going to eat up this much amount of energy from him and dissipate in the form of heat. Friction. Whenever friction is there, the road will become warm, the sole will become warm. Did you understand? Third concept, how many forces are there? Work done by normal reaction, work done by 6 Newton, work done by weight is how much beta? 0 joules. Why? Because they are perpendicular to the displacement. And I told you when theta is 90, how much is the work done? 0. So this is the concept when it is perpendicular to what? Displacement. Either it has to be parallel or anti-parallel, acute or obtuse. But if it is 90, work done by the perpendicular forces always has to become what? 0. So they are not doing any work. Work is either done by this, that is positive work done, and friction is doing which work done? Negative work done. Positive work done means supply of energy. There is someone to supply. Usme se he will eat up some amount of energy. Because you have to move it against friction, you have to break the cold welds. And whatever is left, that will be the resultant work done. Stop. We can write in the end that for block to move, the driving force should be greater than Fs. And if I see over here, the driving force was 8 Newton and Fs is how much beta? 5.6 Newton. The block will move. Otherwise not possible. The question will stop in the starting only. Work done by variable force. In the first section, F was constant. It was not a function of time, neither of displacement. First point, force is a function of x, suppose. Will change with respect to x, na beta? X square plus 2x, whatever. How to find work done? Work done will be F into dx. You take a small element and then integrate that from x initial to x final. You take a small element of f dx and then you integrate that element from initial value to final value. Remember, you take small samples. So small sample of work done is f dx. And then you integrate that from initial value to final value. Example. अच्छा, यहाँ पर don't worry about positive or negative sign. Don't worry. Cos theta, cos 180, cos, we have to worry na initially. You don't worry over here. Mathematics will give you correct answers. Okay. In the second case, you need not worry about that. First case, obviously, positive work done, negative work done, you have to see. I'll give you an example, you will understand. Suppose f is given as 2x. Function of x, variable force. You analyze first. Find the work done in going from x is equal to 4 to x is equal to 2 meters. Find the work done. So once you analyze it as a function of x, apply the formula. What is the formula? Work done is initial to final. What is f? 2x dx. Initial to final, initial is 4. Final is 2. Integration of x dx. Let's say x square by 2. 2 will cancel, become what? X square. 2 4. Upper limit minus lower limit. It will become what? 2 square minus 4 square. You can see mathematics give you minus sign. Sir, I understood mathematically, but I didn't understand the concept. Very simple it is. Beta, the force is plus or minus? Is a positive function. Displacement from 4 to 2 is negative or positive? See, this is a positive force. And the displacement going from 4 to 2, the displacement is what? Negative. And work done is what? This into this. So positive into negative will come what? Negative force. Mean this much is the gain of energy. 12 joules is the gain of energy that is supplied to someone, is taken by someone. I'll give you another example. F is given as minus 4x cube from x2 meter to x1 meter. Find the work done. You analyze it as a function of x. Work done is integration of f dot dx initial to final. Minus 4x cube. Integration 2 to 1 is the integration of this. X cube dx. x4 by 4. So 4 and 4 will cancel. So it will become what? Minus x4 2 to 1 minus sign 1 raised to 4 minus 2 raised to 4. How much is the answer? Minus 15 and minus will become what? Yes or no? Now if you see, the force is, the displacement is, the work done has to be positive. Look na baba, very simple. So, this is the case. Come on, do it. Third case. Area under fx graph. If fx graph is given, you know, when you look at the graph, is this a constant force or a variable force? Variable. X जैसे बढ़ रहा है, force is also increasing, becoming maximum and then decreasing. Variable force. We have learned in the second part that you take a small element f dx. You take a small element f dx, na beta? F dx. This displacement is dx and this is f. So you take f bar dot dx bar and then you integrate from x initial to x final. This is the work done, na? You learned it. What is this going to give you? When you integrate this from x initial to x final, this is going to give you area under this whole graph. This element plus this element plus this element plus this element is going to give you what? Total area. So whenever a graph is given, rather than calculating this, you can do it as area under the fx graph. Is what? The work done. Very good. That's first point. Second point. Okay. We need to get positive and negative sign. You need to worry about the positive and the negative sign. The mathematics will not give you the correct answer. Okay? We'll see how. Suppose I give you an example. It's a graph. F versus X. Pay attention. It's there. It's F. It's X. This is 10 Newton. This is 4 meters. This is also minus 4 meters, and this is 4 meters, and this is what, minus 10 Newton, right? Always remember the area under the fx graph is the projection along the x-axis only. This area will be which area? It will be this area, which is made with the x-axis. Can I say this is area 1? And this will be area 2 now, which is made with the x-axis. Now if they tell you in the question that find the work done from minus 4 meter to 0 meter, the first case. Find the work done from minus 4 meter to 0 meter. In this area I need. Na? What is the area under this curve? Come on, tell me. Half base height. Na? Base is how much? 4. Height is how much? 10. How much will be the answer? 20 joules. But we need to worry about the sign. Can anyone tell me plus or minus? We have to see. Minus 4 to 0. The displacement is positive or negative? The displacement is positive or negative? Positive. And the force is also plus? Plus. Bolo. Displacement is also positive and the force is also positive. You getting it? Displacement is positive and force is also positive. This is the answer. Second case. If I tell you work done is how much? From 4 meter to 0 meter. Okay, you will see how. 4 meter to 0 meter, this area will come, no? How much will be the work done? Half base height. How much is the base? 4. How much is the height? 10. How much is the answer? 20 joules. Can anyone tell me plus minus? Look again. From 4 to 0, displacement is positive or negative? Displacement is positive, negative. And the force is also negative. Force is also negative. And displacement is also from 4 to 0. It is negative. Of this negative will become what? Positive. Do you understand? Did you get it? I'll give you another scenario. Okay, sir. Some doubt? 4 to 0, displacement negative. 4 to 0. And force is also negative. So negative of negative will become positive. I'll give you this by another method. I can do this by another method. You copied this much? No. Achha, copy first. Come on. Listen to me. It's method 1. I'll convert this question into type 2. What is type 2 question? Work done by variable force. Can I convert this? Yes. Can I say, is this force a function of x? Yes, it is a straight line. What is the equation of straight line? Y is mx plus c. What is y? F. What is m? Slope. 10 by 4, no? y2 minus y1 upon x2 minus x2. 10 by 4. But the slope is minus, no? It's going down slope. So it will become what? 10 by 4 is what? 2.5. So can I say this as minus 2.5 x and it is passing through the origin, so intercept will become 0? You can see I have converted as a function of x. So f will become minus 5 by 2x. This is my function. Look now. Now you want to go from minus 4 to 0, integrate. I'll do the first part. Work done will be integration from initial to final. F dx. Correct, na beta? You integrate and see, it will become minus 5 by 2. X square by 2. Minus 4. Minus 5 by 4. 0 square. Minus of minus 4 square. 16. You can see 4 4s are 16. Minus 5 into minus 4 will become what? Plus 20. Similarly, if you do from 4 to 0, you integrate 4 to 0, same thing. You will get plus 20 only again. Okay? So this is how you convert it into the type 2 and do the sum. Work energy theorem. First point. If two or more forces are acting on a body, if two or more forces are acting on a body, if two or more forces are acting on a body, then the work done by all forces, work done by all forces, all, underline all forces is equal to the change in kinetic energy. Change in kinetic energy. That will be kinetic energy final minus kinetic energy initial. That will be half m v final square minus v initial square. This will be work done by all forces. This is a very important formula. Work done by all forces is the change in kinetic energy will become final minus initial. Never you will write initial minus final. Second point. Acha, if initial velocity is 0, then work done by all forces will become half mv square only here, because initial is 0. Second point. Although work energy theorem, although WET, work energy theorem, is applied in all conditions, but mostly it is used to find work done of a force whose variation is not known to us, whose variation is not known to us, provided all other forces are known, provided all other forces are known. This point you will understand in the example. Right now keep it pending. When I will do the example, you will understand this point by an example. Third point. Work done by gravity. Work done by gravity is plus minus mgh. Plus minus mgh. Achha, can anyone tell me when it will be minus mgh? When the body goes up. Because where is the gravitational force? Down. And where is the displacement? Up. And when it will be plus mgh? When the body comes down. Yes or no? And the body is moving at the same level then? How much is the work done by gravitational force? 0. Because what is mgh? H is the difference in the height. H is not the height. Difference in the height matlab kya? This height is taken to be 0. This height is h. So difference will become h minus 0 will become h. Actually it is h1 minus h2. One sec. H stands for difference in the height. ठीक है? We'll take an example so that you can understand. Example 1. A ball of mass 2 kg is thrown up with a velocity of 4 meters per second. It goes up, comes down and hits the ground with 2 meters per second. Goes up, comes down and hits the ground with 2 meters per second. I need to find work done by air resistance. during the whole journey. Work done by air resistance. You know this. Okay. Now see how to analyze work energy theorem. You know V initial and V final is given. V initial, V final. Can I say work done by all forces is the change in kinetic energy half m V final square minus V initial square. Pay attention. Half m is 2. V final square 2 square 4. V initial square initial 4 square 16. Yes or no? How much is the answer? Minus 12 joules. But this is work done by all forces. All. They've asked you only air resistance. Who all are involved? Which two forces are involved? Gravity is involved, yes. So it will be work done by gravity, gravitational force, and work done by air resistance. They are telling you, no? Other forces are there. Spring is there. No, nothing is there. Can anyone tell me how much is the work done by gravity? Same level. Right now I told you. If it is same level to same level, how much is the difference in the height? So how much will be mg, h will be 0. So work done by gravity will be 0. Did you get this? This explains the second point also. This helps you to analyze the variation of a unknown force where all the other work done due to all the forces are known. So you knew the work done due to gravity is 0. You can find the other work done ka variation. Did you understand? Start. Next question. Give you a mass of 2 kg. Okay. The displacement is varying as 2t square. At time 1 second the displacement was 2. Time 2 seconds 2 square 4 2s are 8. The displacement is 8. Vice versa. This is changing. It's a function of time. Find work done by all forces from 2 seconds to 4 seconds. How to do, I'll explain. Then you all will do. Mass is given. What is work done by all forces ka general formula? Half m V final square minus V initial square. So we need V. How to get V from x? अरे डेरिवेटिव, फर्स्ट डेरिवेटिव. इसका डेरिवेटिव लेंगे तो v मिलेगा. कितना हो जाएगा v? 4t. Then put t as 2 seconds, you will get v initial. Then put t as 4 seconds, you will get v final. Put it in the general formula, I'll get the answer. Come on everyone, do it. Concept. Conservative and non-conservative forces. Conservative and non-conservative forces. First point. Conservative forces. Conservative forces are path independent. Path independent. What do you mean by this? First level and this is the second point. Second state. You're going by this path. or this, A, B and C, can I say work done along path A is equal to B is equal to C? Can I say it is path independent? It depends on initial state and final state. Second point, in a closed path, total work done is zero. You can write in bracket the initial state and the final state are the same, because you are returning back by the closed path, na? So the initial and the final states are the same. Third point, very important. Third and fourth point are very, very important. The word potential energy is only associated with conservative forces. Okay, beta? We think potential energy. Acha, what is potential energy? It is the stored form of energy. Energy due to virtue of its position. We don't remember all that. We just remember the stored energy is the potential energy. And the physicists have made potential energy word to understand conservative forces. Or whenever there are conservative forces, there is some stored form of energy. You understand what's happening? In gravitational force, potential energy was there. In chapter named as electrostats, potential energy was there. You learn tomorrow spring force, potential energy will be there. So there is some stored form of energy, but in friction, energy was dissipated, not stored. So the word potential energy will not be associated with friction, with viscous force, with air friction, because it is dissipated in the form of heat, sound. So the word potential energy is only associated with conservative forces. Put it in your mind, please. Okay, you can't apply potential energy formula in friction chapter. Did I apply? No, we didn't apply only. But we did gravitation chapter, remember? Potential energy minus Gm1 m2 by r. Potential energy in electrostats 1 upon 4 by epsilon naught q1 q2 by r. Potential energy of a spring half kx square. Those who have done with me. Friction में नहीं था. Air friction, viscous force में that potential energy word will not come. Next point. If only conservative forces act on the body, then the total mechanical energy is always constant. Means what? Remember in gravitation chapter I used to do Ke plus Pe initial is equal to Ke plus Pe final. You write in bracket. Ke plus Pe initial is equal to Ke plus Pe final. Ke plus Pe initial is equal to Ke plus Pe final. There is no loss of energy in gravitation, in electrostats, in spring force. Example. Next point. Example. Conservative forces are gravitational force. Electrostatic force, spring force. Gravitational force, electrostatic force, spring force. It's about conservative forces. Now put the heading as non-conservative forces. Non-conservative forces. Non-conservative forces. Example, frictional force. Friction force. Viscous force. Frictional force, viscous force. Next point, in non-conservative forces, the total mechanical energy may or may not remain constant. May or may not remain constant. Put the heading as concepts of potential energy. Concepts of potential energy and difference in potential energy. Concepts of potential energy and difference in potential energy. Okay, this I'll be continuing in the next lecture. Thank you.